All right, here we go. Another video lesson for today. What shall we talk about today? We will talk about angle measure. You will learn how to measure and classify angles, and we will identify and use congruent angles in the bisector of an angle. We might also, if we get a chance, use a protractor and try to work with how we can use those to help us measure angles. But that will be in class. Okay, so before we get started, actually looking at angles, let's talk about a term. A ray is part of a line with one endpoint and extends infinitely in one direction. So notice here I have a line, that's a ray, with M and O points. Points M, N, and O. Okay, so I can say that I have a ray MO. Notice how I draw a ray with a line and an arrow going in one direction, and I have a line or a ray MN. They're both on the same plane or same line, but obviously with different names. But do notice that I started with the M because that's my starting point. That's that end point. So that end point is that starting point. That has to be first. Okay, when you're like describing an array. Okay, if one point starts a ray or rays which are collinear, they are called opposite rays. I should say they are called. I didn't know why I didn't use the word called. All right, so those are opposite rays. So you can see here, starting at J goes JK going this way on line L, and JH going the opposite way. Oh, that's why they're called opposite rays. Or opposite rays. So there you go. So you can kind of see here, like, and keep in mind there's something special about opposite rays. We'll be able to talk about how they have a certain degree measure. Of course, we need to know what a degree is, but that's a whole other story. Okay, so two non-collinear rays, notice they're not on the same line, with a common endpoint, like this one, X, form an angle. Okay, at the angle we have what is called a vertex. Okay, that point where they start at, kind of together, form together, that's called a vertex. Now, the rays that make up the angle are called the sides. So, I can say here that the sides are, okay, so my vertex is vertex X, and the sides are XY and YZ. Rays XY and YZ, or XZ. Did I say YZ? It's the first time. Anyways, rays XY and rays XZ. Okay, now keep in mind, there's different names I can give this angle. I can call it angle X, based on the vertex. I can say YXZ, based on the 3 points that make up the angle. But notice that the vertex is in the center. That is important. Or I could say ZXY. Again, notice that the vertex is in the center. Or if there was something here in the middle, like a name, like in this case a 3, I can say that's angle 3. Whatever is in the interior, the smaller part. Okay, so if I have something like this, by the way, y'all don't forget, y'all can pause me anytime so y'all can make sure y'all copy stuff like this. Anyways, if you have something like this, and let me highlight something here. Let's say, like, if I were to continue this, I would have something like okay, that highlighted area would be called the interior. Okay, and then the part that's out, or say not there in the highlighted area, would be called the exterior. Generally, again, think of like when we're thinking less than 180 degrees, the interior is the part that's like inside the angle, okay, not going on the outside. Angles are measured in units called degrees, and we can classify them based on those degrees. We can have a right angle, which is equal to 90 degrees. We can have an acute angle, which is less than 90 degrees. And we can have an obtuse, which is more than 90 degrees, but less than 180. So keep that in mind. It is more than 90, but less than 180. So angles are measured in units called degrees. So don't forget that. Again, pause me if you need to so you can make sure you copy down everything because I am moving on. Alright, so let's look here. We have a drawing here, and we have right, acute, and obtuse angles. I want you to identify the right and acute and obtuse angles. Well, to be honest, you cannot tell me any of them are right until you see, like, say, something like this symbol. When I have a little box like that, or if I were to put 90 degrees, then that would indicate that that angle, in this case MJP, is a right angle. Okay. Now there is a theory or a theorem that we will discuss later that talks about how two opposite rays. Notice that JK and JP are opposite rays, and they are bisected by M. In other words, they are M cuts them in half and makes the 90 degrees. That would suggest that M or KJM is also going to be 90 degrees. But again, that's a theorem that we will talk about later. Anyways, I could also say NJP is acute, and I could say LJK, notice I went LJ to K, is acute. And I could also throw in obtuse, LJP, and or KJN. Now, whoops, didn't mean to do that. Let's do that again. Are those the only acute angles I have? No. See if you can find a couple more, and maybe you can show them to me in the notes. If you show them to me circled, and they are correct, I will make note and add 5 points for the first test. Okay? But again, that's kind of like a little extra bonus. Okay, angles that have the same measure are called congruent angles, so don't forget that. Notice here that, like, say WYZ and WYX are both 80 degrees, so those are called congruent angles. Any ray, in this case YW, that divides an angle equally is called an angle bisector. Okay, so YW is an angle bisector of XYZ because it cuts it into two equal halves. This big angle here into two equal halves. Now, take notice here that this right here is a symbol for congruency on angles. When you see two little arcs like that, that's a symbol for congruency. Okay, that means that they're the same. Alright, so here's our final example. Most of this is just about naming things and understanding stuff, so nothing that hard. Nothing, whatever. Okie dokie. So here we're saying we got this drawing, and we're saying that rays KJ and KM are opposite rays. So these two are opposite of each other. Okay? KN bisects JKL. Now again, don't go with that. I drew this at at scale because I just freehand draw this. So don't start trying to say, oh, well, I measured this, sir, and it came out wrong. Don't be that technical. Anyways, but I'm now saying that this KN divides JKL evenly. And if JKN is equal to 8x minus 13 and NKL is equal to 6x plus n, find the measurement of JKN. Angle JKN. I should have an angle there. Oops. All right. So what does that mean? That means I'm saying because this bisects KN right here bisects JKL, then those two are equal. Okay, they're congruent. And then I'm saying that JKN is 8x minus 13 and NKL is 6x plus 11, and they're congruent, so that means those two are equal. I can set them equal to each other and solve. And then, like we did in, like, say, a last quiz, or like in back the first week, we can solve this. Variables to the left, numbers to the right. The 6x would move to the left, become a minus 6. The minus 13 would move to the right, become a plus 13. And then I would say 2x is equal to 24. So x is equal to 12. Now, does that mean I'm done? No. The question is asking what is the measurement of this angle. So I need to put the 12 in place of the x and solve and say 8 times 12 is 96. 96 minus 13 is 83. So the measurement of angle JKN is 83 degrees. And that is it. And that's all for today's notes, guys. Thank you so much for your time and good luck. And I will see y'all when I see y'all. Thank you so much for your time. Take care.